Hey folks, Mr. Dell here. We are looking at a problem that has us decide whether statements are true or false and give some reasoning behind that decision. So this is a problem from CPM. This is CPM's Math 2, so Integrated Math 2. And this is from section 7.1.4, specifically number 7-52. So it says decide if the following statements are true or false. If a statement is true, explain how you know it's always true. If a statement is false, provide a diagram or description of a counter example to kind of show that it is false and why it's false. So it says, if the diagonals of a quadrilateral are congruent, then it's a rectangle. So is that always true? So if I have the diagonals of a quadrilateral and they are congruent, will it always be true? So let me think about that. So quadrilateral. So I know I have a rectangle, right? And those two sides, those two diagonals are congruent of a rectangle. We know that. But is there another example that I have congruent meaning equal diagonals, and it's still a quadrilateral? And quadrilateral meaning there's four sides, right? So I can think of another example, and it's this guy here. This is an isosceles trapezoid, right? So this is a quadrilateral. So if it's an isosceles trapezoid, that means the two opposite sides there are equal. So if I draw its diagonals, I also know that those diagonals would be congruent. So those diagonals are congruent. So the isosceles trapezoid proves this to be a false statement. Okay, so we'd say false. And then I got my diagram, but I'll write it down. It could be an isosceles triangle, or it's trapezoid. Okay. All right. What about B? If a quadrilateral has four congruent angles, then it's a rectangle. So once again, a quadrilateral just means it's got four sides. So I can draw any shape here with four sides. So I want to show you what do we know about every quadrilateral? Well, if I cut this thing with a diagonal, I really have two triangles, don't I? And every one of these triangles, the angles of those triangles, each of these triangles, the angles of all three triangles add to 180. So within here is 180 degrees, and within here is 180 degrees. So therefore, the quadrilateral has a total of 360 degrees, right? So if it has four congruent angles, then it's a rectangle. Well, in order to get four congruent angles, I would take 360, divide by 4, and that would be 90. So the only way to have four congruent angles that add to be 360 would all of them have to be 90. And if you have four 90-degree angles in any quadrilateral, it has to be a rectangle. So this statement is true. See, all rhombi are parallelograms, right? Rhombi are rhombus. What's true about a rhombus? A rhombus has four equal sides. What's also true about a rhombus is we know that, yes, all the opposite sides, as to say, are parallel to each other. So all rhombi are parallelograms because parallelograms mean that you have opposite sides are parallel. So this is also true. Last one. The diagonals of a parallelogram bisect the angles. So a parallelogram is any quadrilateral where the opposite sides are parallel, correct? So here I drew a parallelogram. So it says the diagonals of a parallelogram bisect the angles. That would mean that these angles, when I draw this, that it would mean that angle is equal to that angle. And is that true? And then also this angle would be equal to that angle. Let's see. So is that true? It doesn't look like it is, right? So if I think about, let me even draw one that's even more. But this is still a parallelogram. So if I drew the diagonal, you can see a little bit more obvious that this angle and that angle are not going to be equal. So diagonal of the parallelogram are not always true. Where is it true? It's only true if the parallelogram is a rhombus, right? Rhombus being that all the sides are also equal. In that case, that parallelogram would have diagonals bisecting their angles. So we'd say false, only true with a rhombus. All right, there we go.